Bernoulli's equation is really for incompressible fluid. So when you talk about air, it's a bit of an approximation. And it's also for frictionless fluid. So when you talk about air, it's a bit of an approximation. All right, there are a number of things about this. It's an approximation in these sense in these cases. But here's some things we're going to talk about. If you look at an incompressible frictionless fluid, and you have Bernoulli's equation, what does it mean? This is what it says. The pressure at some point plus 1/2 the density times the velocity of fluid squared plus the density times acceleration of gravity times the elevation of the fluid, where you are in the fluid, is a constant. Well, when you look at all these terms, what they really come down to is this is essentially conservation of energy for the fluid in a per unit volume sense. So 1/2 rho v squared is just like 1/2 mv squared. So this is the kinetic energy of the fluid in essence. It's not quite the kinetic energy of the fluid, but it's in essence the kinetic energy of the fluid. Rho gh, that is in essence the gravitational potential of the fluid. And this pressure is work being done on the fluid. And so if you want to think about this in terms of other things we've done this semester, this is like the work being done on it. This is the kinetic energy. This is the potential energy. And all we're saying is that in this fluid, incompressible frictionless fluid, right, that energy is conserved. That's really what Bernoulli's equation comes down to. It's conservation of energy. And that conservation of energy principle, conservation of energy per unit volume, um, because this is mass per unit volume, um, work, if you will, per unit volume, pressure. That conservation of energy um, allows us to make some other conclusions, right? So if we look at two different points in a fluid, then because if we're looking at two different points in a fluid moving along, and energy and going from one to the other has to be conserved, we can write the Bernoulli equation like this, that the energy is a constant. So if we pick two different points in the fluid and we got two different velocities, two different heights, two different pressures, but all of this has to work out because energy is conserved. And that's kind of the big picture for Bernoulli's equation. It's conservation of energy for fluids. All right, um, we'll get on to more in the next video.